Hi, this video is about diffraction. In addition to reflection and refraction, waves can be made to change their direction due to diffraction. Diffraction is when waves are bent around objects. When a wave moves past an object or through a tight gap, the edges of the wave spread out. The edges of the wave diffract. The extent of diffraction depends on the wavelength of the wave and the width of the gap. There are three broad scenarios. The first scenario is when the gap is much wider than the wave's wavelength. When this is the case, there is little diffraction, meaning that the waves continue pretty much in the same direction, and we can see that on this diagram. So as the waves approach, they go through the gap and they pretty much stay in the same direction. There is no diffraction of these waves. The second scenario is where the gap is slightly wider than the wave's wavelength. Here, only the wave at the edges diffract and change their direction. So here we have a diagram for the second scenario. We see that the waves approach, and as they pass through, only the edges of the wave start to diffract. The third scenario is when the gap is very narrow compared to the wave's wavelength. When this is the case, the waves diffract greatly and go off in all kinds of directions. We can see that from the diagram, so the gap here is much smaller than the other two cases, and this causes the waves to diffract greatly, and this is why the waves are semicircled here. So to summarise these three scenarios, when the gap is much wider than the wave's wavelength, we have little or no diffraction. When the gap is slightly wider than the wave's wavelength, only the waves at the edges diffract and change their direction. And the final one is, when the gap is very narrow compared to the wave's wavelength, the waves diffract greatly and go off in all kinds of direction. However, we need to remember that the same gap will have different effects on waves that have different wavelengths. For example, suppose that we had two waves, one with a very long wavelength and the other one with a very short wavelength. We then make these two waves travel through the same size gap. When the very long wavelength travels through this gap, we could have scenario 3 occur, whereby the wave diffracts greatly. However, when we put the wave that has a very short wavelength through, scenario 1 could occur, whereby we have little or no diffraction. Therefore, the same size gaps will have different effects on different waves. An easy way to think of diffraction is to think of a harbour with waves travelling through the gap where the boats come in. When the waves come in through the gap, they then spread out across the whole harbour. For more videos, content, quizzes and past papers, go on to www.elevise.co.uk.